I wasn't quite right last time, was I? It was the end of question 2.1, and now we're moving on to question 2.2. And what does 2.2 say? So now we've got market power in a permit market rather than in the product market or the goods market, whatever you call it. So we've got an industry composed of a bunch of firms, and the firms have these abatement cost functions, and we're assuming there's some laissez-faire level of emissions, E bar. And then each firm is given some number of permits, and they then trade. And what have we got? Furthermore, NE bar is greater than the sum of the ZIs. Ah, yeah. So, total initial emissions are more than the number of permits. So, the permit constraint is binding. Derive a condition for firm I's emissions as a function of the permit price. Okay, so this is a little bit tricky, isn't it? But it's the typical kind of thing that you're being asked to do in these problems. You've got to put yourself in the position of the firm, put yourself in the position of the planner sometimes, or the regulator, and think like, what is my profit maximization problem, or what is my social surplus maximization problem? Okay, so here we've got the firm. And the firm I is trying to maximize pi I. Okay. And what is pi I? Well, how can the firm make money? So I guess there's some like pi I star, there's some baseline level of profits, isn't there? If you like, but that's just constant. So as soon as we take first order conditions, that's going to drop out every time. Okay, so we don't really even need it there necessarily. But then, if the firm manages to sell permits, it's going to make money, isn't it? So that's going to add to its profits. And how much revenue is it going to get from permit sales? It's going to get the permit price, PZ, times the number of permits that it sells. So how many permits is it going to sell? Well, it's given ZI, actually it's called ZI bar, but we don't really need the bar, so I'm just going to drop it here. Okay. The firm is given ZI, so if it emitted nothing, it could sell all of those and make revenue PZ ZI. But actually, the firm is going to emit something, isn't it? So we need to call that emission something. Let's call it EI. Okay. So if ZI is 10 and EI is 6, then it's going to be able to sell 4 permits, isn't it? 10 minus 6. If ZI is 10 and EI is 20, then it's going to have to buy permits, and this term is going to be negative. Okay, but there's another term in this function, profit function, which is always going to be negative or not positive anyway, and that's the cost of abatement. And what are we told about that? We're told that it's abatement squared. But what's abatement? Abatement here is interpreted as the reduction in emissions. And we're told that in baseline emissions are E bar. So abatement is the difference between baseline emissions and and actual emissions. E bar minus EI. So if EI is equal to E bar, there's been no abatement and this is 0. If emissions are 0, then the whole of E bar is abated and you have your full costs. So we have some constraints as well, don't we, on the allowed level of EI. We need to bear that in mind. EI can't be negative, but it can't be bigger than E bar. If we were being very formal, we would be writing down all these constraints the whole time. But I'm not big on formality in maths. We're just going to bear them in mind, okay? And we should write, if in an exam you should write down, we need to keep track of the constraints. Okay. Derive a condition for firm I's emissions as a function of the permit price. Okay, so we've set up firm I's problem in terms of just one choice variable, which is EI. We could also set it up in terms of AI, and then we'd have AIs here and here. Let me remind myself the question. Firm I's emissions as a function of the permit price, which is ZI. So that's in here too. This is, it's PZ. So this is looking good. The first order condition in EI, the first order condition, gives us what? Minus PZ minus 2 times all of this, go inside, you get another sign change, so it's plus 2 E bar minus EI equals 0. Right. Got minus 2 times that, then you go inside and get a minus sign. So minus this plus this equals 0, which is basically saying that these two are equal to each other. Okay, so that's the condition for EI as a function of the permit price. Well, it's not really, is it? We want to rearrange this. So if we take that divided by 2, and bring the EI over, we get EI equals E bar minus PZ over 2. That's a better answer. Okay, second part, find the permit price in terms of E bar and Z, the total permit allocation. Okay, I'm getting tired here. Still, I'm going to get this question done and the next one, then I can go home. So, this is single firm. We need to bring in what we know about all the firms. So what do we know about all the firms? We know that N times EI must be equal to Z, don't we? I think. Because it looks to me like all the firms are going to end up emitting the same amount. There's no I's on the right hand side here, are there? So whatever I is, each firm is going to emit the same. Because their E bars are all the same and they're all facing the same permit price. So then we can just multiply by N to get all the firms. If the firms were emitting different amounts, we couldn't do that, right? But we can in this case, so we can just say NEI equals Z equals N E bar minus PZ over 2. Because aren't these things all known apart from PZ? I think they are, aren't they? So if we take that over Z over N, we can get rid of the brackets. So then we can bring the PZ back, and we can say that PZ over 2 is E bar minus Z over N. And that's the 2, which was underneath there. So PZ is 2 E bar minus Z over N. And I'm going to pause and have a look at my crib sheet. Okay, so far so good. Now we're going to look at part B. And in part B, we've still got N firms. I could maybe have stated that a bit more clearly. There's still N firms, but one of them is given all the permits, and it's then free to sell them to the others. And it then has market power. It's not a price taker. It can make a take it or leave it offer to the other firms. How many permits do you want at this price? So then the question is, what price is that firm going to take? And we have to assume that it only has market power in the permit market. It doesn't. There's no other market power going on here. Okay, so what is that firm's problem? We called it firm J, I think, didn't we? Or it's called firm J now, because it's kind of special and different from the other firms. So is this the problem? It's maximizing profits, which are the baseline profits, plus the permit price times Zj now. So now it's given the full Monty, isn't it? It's given Z permits. And it can sell Z minus Ej. That's the number it's going to sell. And it still has these abatement costs. Okay, I need another wee break. Okay, so, tricky stuff this. So the firm is choosing Ej to maximize this. This is straightforward. The tricky bit is Z, and PZ. The tricky bit is PZ. Because depending on how many permits the firm sells, that's going to change PZ. And the firm is aware of that, and it's playing a strategic game to maximize. Okay. So, how many permits does it sell? It sells Z minus Ej. What are the other firms willing to pay for those permits? Well, we need to look at each one of those firms separately. How many permits does one of those firms buy? Well, they're all the same. So each firm, there are n minus 1 other firms, n altogether. So each firm is going to buy that many permits, aren't they? And in the previous part of the question, we worked out what that meant for what the relationship between the permit price and emissions. We worked out that PZ was 2 E bar minus Z over N, where Z over N is the number of permits that each of the firms has. But now, each of the firms, the price-taking firms, doesn't have Z over N permits, they have Z minus Ej over n minus 1. So we can replace that by that. So that is, firm J knows that if it emits Ej itself and sells Z minus Ej permits, so the other firms, the price will be Pz 2 times this. So we can put this in here, and we can say equals pi j star plus 2 E bar minus Z minus Ej over n minus 1 times Z minus Ej, blah, blah, blah. So this is firm J's problem. We've got it, we've done the hard bit, we've set the maximization problem up. Now all we need to do is take first order conditions. The first order condition in Ej so how do we do that? Well, perhaps we should simplify a bit first. So what do we have? We have 2 E bar Z minus Ej minus 2 over n minus 1 Z minus Ej squared, don't we? Minus E bar minus Ej squared. So if we take the first order condition, we end up with minus 2 E bar minus, differentiate this, we get 4 over n minus 1. Go inside, we get a minus sign. So we get plus 4 over n minus 1, Z minus Ej. Differentiate this, we get minus 2 times this. Go inside, we get a minus sign, so we get plus 2 E bar minus Ej equals 0. Which isn't looking too bad at all, is it? So if we collect terms in Ej on this side, but then take a mirror image, we end up with 2 Ej plus 4 over n minus 1 Ej, or 2 plus 4 over n minus 1 times Ej equals, so that's that taken over and that taken over, and the rest is sort of still on this side. So we've got 4 over n minus 1 times Z plus 2 E bar minus 2 E bar, so that's just cancelling. Okay, so if we multiply or divide both sides by 2, we get 1 plus 2 over n minus 1 is 2 over n minus 1z. If we multiply through by n minus 1, we get n minus 1 plus 2 equals 2z. n minus 1 plus 2 is n plus 1. So we get Ej is 2 over n plus 1. Z. Is it right? Let me check my crib sheet. No. Ej is 2n minus 1 over n plus 1 z. Oh! Okay, I'm going to have a look at this. Okay. I found the problem, another careless mistake. Let's try and simplify this. Minus 2e bar plus 2e bar. So we can wipe these. Minus 2e bar plus 2e bar. So those go. So then we have, and again we collect terms, or let's divide by 2, like that. Now we collect terms in Ej, so we have Ej 1 plus 2 over n minus 1 equals 2 over n minus 1 z, multiply through multiply through by n minus 1, and we have n minus 1 plus 2 is n plus 1 equals 2z. We get exactly this, sorry. Okay. So, if we compare to what are emissions in the perfect market, they are Z over N, aren't they? From each firm. But here we have 2Z over N plus 1. So if N is 3, for example, we'd have Z over 3 here, and here we have Z over 2. Right. And this is the monopolist, J. So the monopolist is emitting more and selling fewer permits to drive the permit price up. And of course the permit price is let me just check. Yeah. So the permit price, PZ, is 2 E bar minus EI. So what's EI? Wow. So this is EJ. EJ plus N minus 1 EI equals Z. EJ 2 over N plus 1 Z. So EI is Z times 1 plus 2 over N plus 1. Sorry, minus 2 over N plus 1 over N minus 1. Times top and bottom by N plus 1, you get N plus 1 minus 2 here, and N plus 1 times N minus 1 here. N plus 1 minus 2 is N minus 1, so that goes out. So EI is Z over N plus 1. Wow. So instead of Z over N, we get EI is kind of cool. So when n is large, there's no real difference in the permit price. Yeah, sorry, the permit price we get by sticking this in there. When n is large, there's no big difference. But when n is small, it makes a big difference. Because the monopolist can really exercise some power.